Welcome back everyone. Today's topic is data structure in Python. So like as we have discussed in our live session about the data structure and what do you mean by the data structure in any of the programming language, as we are discussing about the Python. So the first topic for the chapter is what is a stack. A stack is a data structure that stores item in an last in first out manner. We also call it LIFO. And like what is the meaning of LIFO? Basically the last item what you are going to insert in the data structure or in a stack will be pop out or will be come out first. It is like you are preparing a stack of books, and the book what you kept at the end, or what you can say at the top, if you want to remove the books, will be pop up first. Fine. So the book you kept last will be pick up at the first. And like basically if we talk about Python programming language and we have to develop a stack, the list is already given and we consider list as a stack and will be implement the program based on the concept of list only. There is no other mechanism to implement the stack basically. And we are going to consider the list to implement the stack. Before jumping on the like programming, we should know how does this stack actually work. So I have prepared something in Excel so that I can let you know how does this stack work. So before starting anything, suppose I have a data I have some data here like 11, 22, 33, 44. We just consider this thing like it's an example of a roll number, you can say, or anything you want to assume. So we just have to insert the data in the stack. Before starting the insertion program, I should tell you there are two operations of any there are two operations of a stack. The first operation is push and the second one is pop. Here the meaning of push is to insert an element into the stack, whereas the meaning of pop is removing the existing element from the stack if stack is not empty. Fine. So the first operation is push. We are going to perform the push operation, and before starting the operation we should know the structure of the stack. Here you can see I have prepared a stack here and it only has one face, or we can say head. So from this side value will be coming down. Fine. It has a pointer named top. Top will always point where the value is. The last value, if the last value is at 5, top will move down to 5. Next I have given max minus 1, which is pointing 5. It means if you ask user what is the maximum limit of a stack and if he entered 7, and because we are going to start from 0, indexing is going to be start from 0, the last element will be 6 in that case. So in our case the last element is 5. It means it has a capacity to store 6 values here. Fine. So let's start. First thing we want to insert is, it means we want to push 44 here. The moment 44 will come here, now if I ask you the value of pointer, the value of pointer is 0 here. It is 0. It means pointer is pointing at 0 indexing and stack has a value item as 44. Fine. Next we want to insert 33. So the moment I will write 33, what should actually happen? The pointer is now going to be changed from this location to this location. It means the new value of top pointer is 1. Previously it was 0, now it is 1. Fine. The next thing is, now we have to insert 22 here. So the moment we are writing 22, the top will move from 1 to 2. The new value of top pointer is 2 now. Next is we have to insert 11 now. So now we are inserting 11 here and top will move from second location to third location. Fine. And the value of top will become 3. So this is how we insert element in a stack, and we call it push operation. The next thing is the top will always point the last element you inserted. Getting my point? And another important thing about this stack, insertion and deletion can be done. It means push and pop operation can be done from this end only. There is no other way to eliminate the element. So now the next operation is pop. Will be more clear now. Then pop means we have to delete the element. As I told you, there is only one way to insert or delete the element. It means we can only insert the data from this side as well as we can delete the data from this side. So now we want to delete the data. It means we want to delete the 11. We want to pop the element 11, because if you want to delete 22, 33 or 44 either, you cannot do that because there is only one way, last in first out. So the first element what we can pop is 11. The moment you will pop 11, it means the moment you will delete 11, the top pointer will be moved back to the previous location, which is 2. So now it is pointing 2. This 3 is gone now. If you want to pop 22 as well, you can do that, and pointer will be shifted to the first location of the stack. So this is how the stack actually works. Fine. You can do this operation with the help of list also. And if you remember, there is one thing in list which was append. One operation, one function was there, which is append. So append and pop function will help us to perform all these operation of a stack. So let's move to the programming. I have already prepared 2 programs, and definitely I'm going to share these programs in my notes with the video. So if you notice, I have already prepared this. So see this, I have just considered here my stack is equals to this list. It means though we are working with this stack, the fundamental of a stack, but we have to complete these things with the help of list, and there is no other way to do this. Fine. So I have taken one list here, name is my stack. Just to let you know that we are working with stack, I have considered the name of list as my stack. Next, I have taken one variable which is for the choice of user to continue or not. So ch is the variable, and I have given the initial value of ch as y. Fine. Next is a loop. So this loop will work till the variable ch has a value y. It means the moment user will press something else from the keyboard, this while loop will be break out. Fine. So in the next statements, I have given choice 1, 2, 3, one for push, second is for pop, and third one is for display. Basically this display is also known as traversal. It means when you are dealing with each and every element of list or stack or queue, we call it traversal. Fine. So in the next statement, we are going to ask from user, enter your choice. It means user has to enter a number here, because we have specifically convert the input into integer here. Fine. The choices are 1, 2 or 3. So if next statement is if user will press 1, it means if choice is equals to 1, it means user has selected an operation to push. It means user wants to enter some values into the stack. How we enter? Because as I have told you, value can be entered from the top of the stack. It means there is only one way to enter the value. It means whatever the value we are inserting will be coming at the end of the stack, or what we can say at the end of the list. And for this we have a function named append. So our problem is solved. How we are going to insert the value? First thing is we have to ask one variable, or we have to ask one value from the user and enter any number here. Next, my stack, which is a list there, you can see my stack dot append. What to append? What user just has entered, which is a. So the appended value is a. It means in the list this a will be add up. And if user has pressed 2, it means he or she want to delete something from the stack. So now if choice is equals to 2, the first thing what we have to check before removing something is, like for an example, if I ask you to remove something from the, you can say, a drawer or from the book shelf, there should be a book available, only then you can remove something. Otherwise, if nothing is there, you cannot remove anything from the existing like data structure. So the first thing what we have to check, whether the values are there or not. So if your my stack, it means if your list is equals to empty, it means you have to print stack is already empty, you cannot delete anything because the list is empty. What we can delete from there? Fine. Else, if it is not empty, even if has a single value, we can delete something. So if it is coming true, we're gonna print the message stack is already empty, we cannot delete anything from the stack. If it is not, it means else, print my stack dot pop. What to pop? The last element already. So last element will be popped up and it is deleted from the stack. So this is how it will work. Else, if user has pressed 3, it means he doesn't want to push anything or pop out anything from this stack. He just want to see the values present in this stack. He is going to press 3. So if he has opted for 3, how we are going to print the stack? First of all, we need to calculate the length of the stack, which is list again. So first of like function what we are like I'm going to use is length. It is going to return the length of my stack function, and this value will be assigned in ln variable. In the next line, I have taken one loop here for I in a range. What is the range here? Len minus 1. It means this ln minus 1 comma minus 1 comma minus 1. What is the meaning of these three minus 1 minus 1 minus 1 like there? So len minus 1, if a like function is returning us 5, it means we are going to start the loop from 0 to 5, it means 0 to 4, and if it is 6, we are working till 5 only. So len minus 1 से मेरा loop start होगा, and we have to decrease the value, we have to reverse the value, we have to print the value in a reverse order. Like I just have explained, if you notice, if it is like this 22 and 11, and if I'm going to print the value, this 11 will come up, and then 22 and then 33 and 44. It means whatever the value was inserted last will be pop out first. So just to perform this operation, we have written this code in the we have taken the loop in the reverse order. And next is I'm going to print my list in this scenario only, how this I will work. Else print you entered a wrong choice. It means if user has not pressed 1 2 3 either, it means we are going to print this message, you entered a wrong choice. Next, the message to continue or not. So do you want to continue? If user is going to press Y, this whole program will work again. Otherwise, if he presses anything else, this program will terminate there only. So now time to take the look at the output of this program. So let's move to the execution part. So here is the program. We have three options here: push, pop, display. The program is asking to enter my choice. I'm going to enter 1 first because we want to insert some value. Enter a number. I'm going to press 11. We want to continue, yes. Again I'm going to push one value. Enter a number. I'm going to enter 22. So what I'm doing, I'm basically inserting some values, which is also known as push in stack. Do you want to continue? Yes, I want to continue again. I want to insert more value here, so I'm taking push. Enter a number, 33 now. Yes, I want to continue. Next again 1. Now 44. Do you want to continue? Yes, I want to continue. Now I want to basically check the values what I have entered are there or not. So the option is 3 to display the stack. So you can see 44, 33, 11, 22 and 11. So now you can see I have entered 44 at the end of the execution earlier. Now 44 is coming up. So this is how the loop will work. It means last to first value. And now do you want to continue? Yes, I want to continue with the program. So the first operation we have checked, it is working very much fine. The last option is working fine, only pop is remaining. So I'm going to press 2 here to pop something. 44 is deleted from the stack. See, we do not have choice to eliminate any of the variable, any of the number from the stack. Automatically the last element what we had inserted will be popped out, as I have explained in the like Excel sheet there. So 44 was at the top of the stack, so it is going to be deleted first. So 44 is deleted now. Do you want to continue? Yes, we want to continue. We want to check the new stack. So I'm going to press 3 again. So this is my new stack, 33, 22, 11. So this is how the stack basically works in the data structure, and we have considered list here to perform the operation of stack. Hope this thing is clear to you. It is very simple. If you guys are okay with list, I don't think this stack will create problem for you. Fine. So next what we are going to study in the same chapter is queue. All the theory and concepts are there in the notes. Definitely I'm going to share these things with you. So what is queue? Queue is again a data structure similar as stack, but it has a different fundamental, and the mechanism of queue is totally different. Let's consider in live an example of queue. The moment you come down for prayer in the assembly, basically you prepare a queue. We like I generally like I always tell you guys, see, it is not a line if it has if every elements of a line is moving, it is not a line. So if you consider this thing as queue is the right thing, fine. So what is queue? Queue is again a data structure, and it works on the fundamental of FIFO. It means first in, first out. It means who the whatever the elements will come first will be pop out first or will move out first. The example, another example for the same thing is like people standing in a queue to collect something from the you can say fee counter or in the bank. The person who will come first will be move out first. So first come, first in, first out. Fine. So I have prepared something with the help of some tables here. So if I ask you, see, there are two things before starting the things I should tell you. There are two things in the queue, front and rear. The front is where the list is going to be, the queue is going to be start, and the rear the last end of the queue. So front and rear are the two things here. Let's consider an example for this thing also. If a queue is there for prayer, if a line of students is there for a prayer, the first student will be at front and the last student will be at rear. Fine. So there are several operations. NQ, add an element to the queue, just like stack we were pushing something. Here it is NQ. DQ means removing an element from the queue. Peek, get the topmost element of the queue, that is the element at the front position. It means the first element की अगर हमारे को location निकालनी हो, so we call it peek. Now empty queue. How to recognize empty queue? If a queue, again we can only implement queue, stack or any other data structure with the help of list, tuple, dictionary, because it is already there in the Python. So if list is empty, you will not get any value of front either, not for rear. If it means front and rear has no value or they are pointing to -1, our queue is empty and we can print the queue is empty. Else, even if has a single element, so what will happen if we consider these things like 0, 1, 2, 3, 4, it means if we consider the indexing for the same queue is 0, 1, 2, 3, 4, so now 55 is at 0 location. So here the front and rear are pointing at the same position. It means front has a value 0 as well as rear has a value 0. Next is front. I have inserted 65 9 and now you can see front will remain same there 0, but rear will be increased as 1. In the next element, inserting third element here, front has a value 0, rear has a value 2. Now rear is at 2 location, 0, 1, 2. Next insert the second element. Sorry, it should be fourth, not second. Fourth, it means now I have inserted 85, so 0, 1, 2, 3. Rear has a value 3. In the same, it should be fifth. Insert the fifth element. So front has a value 0, rear has a value 4 because 0, 1, 2, 3, 4. So these were the example of NQ. It means when you are inserting the element, basically the front will remain same, only the rear will be increased. Fine. Now the deletion from the queue. So how does it work? Now if you want to delete something from the queue, you can only delete from the front. Like we had one face in a stack, now we have two face in queue, but we can only delete one element from the front only. We cannot remove anything from the rear side. So if you want to delete something from the queue, what you can do? You only have to remove it from the front end. So now front is equals to 0, rear has a value 4 here according to this queue. If I want to delete 55, front will remain 0 and rear will remain 4 now, but 55 is basically gone. In another scenario, if you want to remove something, it means you have to increase the front. First of all, the front was pointing here and it has an indexing value as 0, but now if you see this thing, the front has a value 1 here, not 0. But in Python, if you talk about list, when you pop up any value from the index, the compiler, the interpreter automatically fix it to 0. It means अब यहाँ पर 65 पे pointer 0 को point करेगा. This 55 is gone from the list, जो कि हमारी list पे है. ये Python में inbuilt automatically वो अपने आप set कर लेता है when you use a pop function. In same scenario, if you want to delete this 65, the front is going to be like changed from 0 to 1, but again it is going to be set to 0. So ये functionality है कि Python में, interpreter में, automatically it works fine. So these are the program I have already given. Next program is for Q as well. So let's move to the programming now. In the next program, I have just renamed that stack with Q, and again I have, as I told you that we are going to work with list only. So like again I have taken one list here, which is name is myQ, same operation. Fundamental will be same, only thing the pop value, it means as I told you the pop can be performed from front, which is going to be 0 again and again. So यहाँ पर कुछ चीज चेंज हो जाती है, हमारे को pop में यहाँ पर 0 इंडेक्स देना पड़ेगा because we can only delete from the front. Next is fine. अगर डिस्प्ले करना है तो यहाँ पर लूप सीधा चलेगा, इसलिए रेंज हमारी 0 से लेके उसकी लेंथ तक रहेगी. नेक्स्ट लाइक रेस्ट ऑफ द थिंग्स आर सेम. सो लेट्स हैव अ एग्जीक्यूशन नाउ. Do you want to continue? Yes, I want to continue. I guess it is working for the last program. Okay, so now the output is there. The first one is add, remove and display. I want to add something to the list, so I'm gonna press 1. I'm gonna add 55 here. You want to continue? Yes, I want to continue, and I want to add it again. Now I'm going to enter 44. Yes, with 1. Now I'm gonna enter 33. Yes, with 1. Now I'm gonna enter 22. Yes, with 1. Now I'm gonna enter 11. You want to continue? Yes. I want to see the elements what I have just entered. I'm gonna press 3. So now you can see जैसा मैंने enter किया उसी sequence में it is there. And if you want to remove something, so do you want to continue? Yes, I want to continue. I want to remove something. 55 is removed. So 55 I entered like at the beginning. You can see in the program even. It is there. So the first in, first out, जो सबसे पहले आया था वो सबसे पहले delete भी हो गया. I want to continue again and gonna press Y here just to check the elements. I'm gonna press 3. See, 55 is not there. So the fundamentals are same, but the difference is the stack basically work only for last in first out, whereas the queue work on FIFO first in first out. Hope these things are clear to you. In this chapter only 2 data structures are given, and I'm gonna, if you do not have a book, I'm gonna provide this notes along with the video. At the moment it will be uploaded on YouTube, you can check this thing, these notes part in the description. That's all for the day. Thank you.